Welcome to myprojectbazaar.com. Our product title is Enhanced Security Constraint OPF with Distributed Battery Energy Storage. Let us see about the abstract of our product. In this proposed system is design a fast response distributed battery energy storage system under post contingency corrective control actions. Immediately after contingency, then injections of distributed batteries could be adjusted to alleviate overloads and reduce flows below their short time emergency rating. This ensures that the post contingency system remains stable until the operator has redispatched the generation implementation. This form of active control would allow operators to take advantages of the difference between the short and long term ratings of the lines and would therefore increase the available transmission capability. This problem is formulated as a two-stage enhanced security constraint optimal power flow problem, in which the first stage optimizes the pre-contingency generation dispatch while the second stage minimizes the corrective actions for each contingency case studies based on a 6-bus test system and the RDS 96 bus system. Demonstrate that the proposed method provides effective corrective actions and can guarantee operational reliability and economic. In this implementation, main important thing, we only implemented using of general available 6-bus and 96-bus system data only, and also that data only implemented for using those objective function and all constraints, and also corresponding waveform only we provide in this implementation. In this proposed paper, some constraint value not given and also the some parameters not clearly given, so we consider that as a general value, so that only we implemented in this implementation. Let us see the flow diagram of our process. This is the given 6-bus system, but we only take the general available IEEE 6-bus system and 96 bus system. In 6-bus system, total having 6 buses and having 3 generators and also 3 loads. So this is the way of bus system implementation. Then for 96 bus system, total having 96 bus system and corresponding generators and loads are available in the overall IEEE general available bus system. In that bus system, only that available bus system, that data is given from the mat file, then that file is getting from in the main coding. In that main coding, that all objective function all derived and that functions will be solved in the mathematical oriented, and also general values only considered to that constraint and also that objective function is derived. Next we see about running process of our product. In this proposed implementation is done in MATLAB. In MATLAB, generally two kind of process can approach. One is Simulink wise, another one M file wise. In this proposed implementation is calculated for mathematical oriented and also the constraints and objective function is derived using of the formulas. So in this process only can do in the M file using of C language codings. So in that given objective functions and all constraint will derived using mathematical function, then that values parameter values are getting from general available IEEE 6-bus system and 96 bus system. So this is the bus data of 96 bus system. So here we have 120 into 13, that is the matrix format, and this is the branch data. Total branches 121 branches. So into 13 is the total values. The first one is the bus from bus, another one to bus, and next one is the RX, that means resistance, reactance, impedance values and so on. And this is the ECM, that is the calculated value. So these are the parameters and getting in from the IEEE general bus data system. So other values are derived from the formulas using in the given objective functions, and all objective functions values are determined by using of the constraint. So two kind of constraint, one is equality, another one equality. In equality constraint the values are derived directly, and inequality constraint, that means that ranges minimum and maximum ranges, in that ranges only the output will be it can calculated. So these are the constraints, equality and inequality constraint. So those values are calculated, and then that values is applied to the which kind of algorithm to use to optimize for the problem, and then that value is fit into that optimized algorithm. Then finally that value is getting from that algorithm. Then we write your coding for the plotting purpose. So which kind of waveform we want to record, and then that waveform is plotted using of that commands. So which label is assigned for x and y, and which is the title for that plot, all of written in the coding format. Then save that file, then click and run that OM file. Then the corresponding output will be shown in the corresponding window. So first one is the 6-bus system before contingency. So here 1 and totally 6 values. Then this is the after contingency for 6-bus system, and this is the 96 bus system. So for before contingency value, this is the after contingency value for 96 bus system. So this is the way to calculate and derive the objective function. Thank you for watching this video.